Hey guys, I'm currently at the 300-yard range, and I'm doing something kind of special. I learned this from, I guess, what many consider the world's best long-range shooter. I don't recall his name. I'll try to post it in the video. But he has done some amazing long-range shots. And he teaches the military, and he's sponsored by a company. And the process he describes is called truing. And what it is to use, and he uses, a ballistics calculator. And he wants to tune the ballistics calculator to the real world so that it accurately represents the rifle and system that he's shooting. The way you do that, and there's some variations, is you zero the rifle, and I did that at 100 yards, and as a matter of fact, here's my target. This was my initial 3 cold bore shots, and they were a ½ inch low, so I adjusted the scope to MOA and shot these. There are 2 shots here and 1 here. Looks like I pulled one, doesn't it? But this upper group is 4/10 of an MOA, this lower group is 0.39 MOA. So I'm zeroed. The next thing to do is shoot at 300 yards at a bullseye, and I'm not changing my scope, and I'm going to measure the drop. From the drop, and I have chronographed my bullets from the velocity of the bullets and the drop. I'm going to calculate the effective ballistic coefficient of the bullet. Now, where the truing comes in, after I've done that, I go to the 200-yard range, look at what my calculator says I should have my scope set to be zeroed at 200, set my scope, fire the shot, and if I'm not right on the zero, then I have to start adjusting the ballistic coefficient to bring it into what it's supposed to be. Now here's the idea. You got a 100-yard zero, you got a 300-yard drop, and we've got a 200-yard intermediate point. So those 3 points, when they come into alignment, that's what the rifle does, and when the ballistics calculator agrees, we're right on. So what's the purpose? The purpose is we have now tuned our calculator to do exactly, or to calculate exactly, what our rifle is going to do in reality. Now, if we have wind and things, you have to factor that in. But as a first level approximation, our ballistics calculator, like this on a windless day essentially, should be pretty right on. So if I could go out to say 400, 450 yards, I should be able to use my ballistics calculator because it's corrected to this ammo, this gun, and this scope, and dial that in. That's what he teaches. So I'm going to do the drop test here, go measure it, and proceed from there. Alright, I've shot 3 shots. I thought I'd spare you the agony of that. And this is going to be my 4th. Now, what the 4th is, it's kind of a makeup shot. In case I did something wrong on one shot, or had a little more parallax in the scope than I had accounted for. So I'll go down there and have 4 shots, and I'll pick the tightest 3. And the reason I want to do that is I think that's going to be the best representation of what the ammo, gun, and drop is going to be. Alright, we will load up, go measure the target, and come back to the 200-yard range. Well, maybe that's not too bad. Let's see what we got here. That's a 2-inch group, and if I, shot that 4th shot in case I had one off, I think that's the off one. So I don't want to change my drop by the influence of this one, so I'm going to use this group. The drop is not as much as I thought it was going to be. It is, I'm going to say 13 inches. So I'm going to put that in along with the velocity I've measured with the magneto speed and a drop of average 13 inches. And I will use that to calculate the effective ballistic coefficient. I'm now at the 200-yard range, and it's test time. I've fed the information about muzzle velocity, bullet drop into my Strelok ballistics calculator. It gave me a ballistic coefficient for this bullet, and I said, okay, what do I need to do to the scope to be right on at 200 yards? So this is a reality check. I've got a target set up, and I'm going to shoot dead center of the target and see if it hits dead center. If it doesn't, I have to adjust something. Now, let me get my spotting scope. I should quit. I just looked through my spotting scope, and it's about that far above center. Now, to measure the velocity, measure the drop at 300, take the average drop group, come back, put all that into a ballistics calculator, ask the calculator at 200 yards, how much do I dial in? It tells me. I dial it in. I'm that close from center, dead center elevation, not that far away from horizontal. I'm impressed. So this thing is working really good. I should stop. I'll probably mess the whole group up with the next 2 shots, but I really need to take 2 more. It's about 3/4 of an inch from the other one. And I should stop. You know, when you've got 2 shots at 200 yards that close, you ain't got any business shooting a 3rd shot at it. I believe I just blew the group. Oh, no, it's right over by the side. I saw a number and thought it was the bullet. That's about a half MOA. We'll go down and take a look at it. That's all I'm going to do here. All right, guys, I'm back at the target stand again. This is the target I just shot. This was the one at 200 yards. I dialed in what Strelok told me to based on the real world parameters I fed it. Let's see what we've got here. That's under a 1 MOA. Actually, that's under a half MOA. 1 inch divided by 2, and that's only about 1 7/8. So that's significantly under a half-inch MOA. Now, I'm sorry, a half MOA. Here we have science calculators, ballistic calculators, agreeing with the real world. Hey guys, now that you've seen the video, there are some things we need to go over. I'll shoot a list of this or a copy of this up on the screen as I talk. And basically what this is about is we wanted to do this. This is our goal, to tune a ballistic calculator so that it will predict real world behavior of a given shooting system. And that includes the rifle, the bullet, the scope, all aspects of it. And the things that are included in the video that you just watched, that was a preliminary test of the concept. It's basically bullet drop with range. The further the range, the greater the bullet drop. Now, it needs to be understood that while I'm using 100, 200, and 300 yards, the purpose in using known yardages is to calibrate, to confirm, to make sure that it's doing what we expect it to do at known yardages. So when we get out in the field at unknown yardages and we measure those and we come up with 275 and 365 and things like that, when we key that in, we want to be sure that we have got our ballistics calculator tuned to give us as accurate behavior of the bullet at that range and drop as we can possibly get. So that's what this is about. Match our ballistics calculator to real world performance. And basically this test was merely bullet drop versus range. Now some things that are not accounted for. Wind, I don't have control of wind, so I can't turn a dial and say that's a 5 mile an hour cross one and this is a 10 and so on. So there's really no point in trying to do that. I was fortunate on this day, it was very still, so wind kind of was out of the picture anyway. Likewise, I didn't include humidity and I didn't include elevation. Those things may come back to haunt me one of these days if I'm shooting at a different elevation, different humidity, but I can always put those in. I just didn't this time because I was only shooting at 300 yards and the range or the humidity and elevation were constant. There's some data I had to put into Strelock. I have Strelock Pro. I think it cost about $8. It's about as reasonable as it can get. The data I put in was my zero range. That was 100 yards. One of the things I had to enter that I haven't mentioned in the video was the scope height. How high the center line of the scope is to the center line of the bore of the barrel. So that has to go in there because it makes a difference. Another thing I put in was the barrel twist rate. This barrel happens to be a 1 in 8. Scope specifics, meaning what power range, but primarily the type of units, whether it's MILRAD or MOA. This one's MOA, so the reason you need to put that in the scope type, Strelock uses that to give you the correction on the elevation for clicks and things like that, so it needs to know that. The other thing I did is I did put the temperature in for today. I think I used 92 degrees for my velocity. I wouldn't need that as long as my velocity is constant for the day. It's going to be the same, but if I did this another day and it's now 30 degrees cooler, my ballistics calculator would have that average velocity of 2615 feet per second at 92 degrees, and it could compensate for temperature, although the ammo I'm using is largely compensated for temperature. Alright, the measured values, the thing that we have to make this thing work with the real world is real world parameters. Well, one of the things we have to have is the bullet velocity, and I got that using a magneto speed chronograph. I really like that. I don't have to worry about screens doing funny things on the light screens, shading causing problems. I don't have to set it up. All I've got to do is put it on. But maybe the bigger thing is My measurement system is about, that far from the muzzle. A light screen type is 10 feet to the first screen. My measuring range distance is about this long between the two sensors. On a light screen it's much longer, so you're getting some average there, and you're getting a decrease in muzzle velocity simply for the bullet traveling from the muzzle to the first screen. So magneto speed is up there, and it's telling you pretty close what that bullet is coming right out of the barrel. The other thing, and this was in the video as well, is the bullet drop. You've got to go to some range. I went to 300. That's as far as I could go. If I could have gone to 400, I'd have probably done that. 300 is not bad though, because you can shoot the bullet that's with the gun zeroed at 100 yards, and it's at least on a large piece of paper. If you get too far out, the drop's going to be so great that may not even show up on the test paper. So we put those two things in, velocity and a bullet drop, and those are measured. We're taking that from the real world. The calculator calculates two things for us. One is ballistic coefficient based on the velocity we have measured and the drop we have measured. Now guys, this was a surprise. I've been doing this the other way. I've been taking the manufacturer's ballistic coefficient, which was 0.301 for this particular bullet, and calculating velocity. You can do it either way. And I found at 200 yards I was still about 3-4 inches high. And I'm thinking, how on earth could that be? Well, what was happening, the ballistic coefficient wasn't correct. Well, I turned that thing around and said, look, I'm measuring muzzle velocity accurately. So I know what that is. What I need to do is see how the bullet drop and that muzzle velocity looks at the ballistic coefficient. So I obtained with my calculator an effective ballistic coefficient based on the bullet muzzle velocity and how far it drops at 300 yards. You know what it was? It was well over 0.4. It seemed like it was about 0.46. I don't have that with me right now. Now you might question the validity of that, but let us not forget, when I used that ballistic coefficient that I calculated, how high was my bullet? No more than a ½ inch high at 200 yards, my test point. See, 100 yards is one of our knowns. 300 yards and the drop is one of our knowns. Right in between those two is 200, and we're using purely calculated data based on those other 2 points to say the bullet ought to go right here if you set this many clicks into your scope. I set that many clicks into my scope and the bullet went right there. Well, it was 3/8 of an inch high at 200 yards. The other calculated value that we get from the ballistic calculator is simply the scope settings. If you're at 375 yards and you tell it that and you say, okay, tell me what I need to do to my scope, you just punch calculate and you dial it in, or you can look at a table. I like to do the calculate. I don't have so many numbers to look at. All right, once we get all that done, what's left? Well, what is left is adjustments. About the only adjustment you can make is the ballistic coefficient. Now you might be thinking, well, what about the scope? Why not just turn it down a notch? Well, you can, but see, that information doesn't get fed back into the ballistics calculator, so the next time you got to remember that I got to go down one, and you don't want to do that. Now what I think I probably should do, I was I don't know, 3/8 of an inch high at 200 yards based on the scope data I got from Strelok. I think what I probably need to do is change my ballistic coefficient a little bit higher, because what's happening is that bullet is carrying a little bit better, which means it has a better ballistic coefficient. So it's hitting a little bit high. Now when you're talking about something like this at 200 yards, you don't want to overreact to that. The next time I do it, it might be right on. So before I do too much, I want to do some confirming tests. But typically, when you're done, it's all said and done, and you're looking at what to do to improve the relationship between the ballistics calculator and the real world, about the only thing you can do is adjust the BC. And my summary remark here would be, I was amazed at how much difference there was in what the manufacturer said the ballistic coefficient for this bullet was and what the calculated ballistic coefficient was. It was enormous. At first I thought, well, it's got to be wrong, but when you've got the 200 and 300 yard points, and then you calculate where you should be at 200 yards, and you set the scope to that, and the bullet goes there, the ballistic coefficient has to be right. That's the only combination, muzzle velocity, ballistic coefficient, and scope setting, that is going to give you that accuracy at 200 yards based on the calculations at the other two ranges. So, all in all, this was an outstandingly successful test. I've learned a lot from it. Maybe you can give it a try and let me know what you think.